For our example in finding the definite integral, as we discussed, we have to find the antiderivative first and then we have to substitute the limit. So in our first example, as the integral of x to the fourth plus 12x cubed minus 2x squared plus 10x minus 4 closed quantity dx. So understood that we have to evaluate it first. We have to find the integral of it first by applying or using the power integral here before we can substitute the lower to upper limit. So we can now find the integral of this. So the x to the fourth dx is just simply add 1 to the exponent. So this is x to the fifth over 5. 12x cubed, so we have to add 1 to the exponent, so it becomes 4. So then this is x to the fourth over 4, and 12 divided by 4 is 3. So we have 3x to the fourth here. And then for the 2x squared plus 1, so it becomes cubed divided by 3. So we have 2/3 x cubed. And then this is understood 1 plus 1, so x squared divided by 2. So we have 10 divided by 2 is 5. And of course, we have the integral of dx is x as for the negative 4 integral of dx. And then we have to substitute the limit from 1 to 2. How to substitute is just simply substitute the upper minus lower. So it becomes, for the x to the fifth, it becomes 2 raised to the 5 minus 1 raised to the 5. So upper limit minus lower limit multiplied by the coefficient 1/5. For the x to the fourth, so this is now 2 raised to the fourth minus 1 raised to the fourth multiplied by the coefficient 3. And then for the 2/3, 2x cubed, so this is now 2 raised to cube minus 1 raised to cube. Again, upper limit minus lower limit multiplied by the coefficient 2/3. And then for the x squared, so we have 2 raised to square minus 1 raised to square multiplied by the coefficient of 5. And for the x, this is simply 2 minus 1 multiplied by the coefficient of 4. 2 raised to 5 here is 32 minus 1, so we have 31 multiplied by 1/5, so this is 31 over 5. We have 2 raised to 4 is 16 minus 1 is 15 times 3 is 45. 2 raised to cube is 8 minus 1, 7 times 2 over 3 is 14 over 3. And then we have 2 raised to square is 4 minus 1 is 3 times 5 is 15. And then 2 minus 1 is 1 times 4 is negative 4. So again, we have to simplify these values. We have 31 over 5 here. And then 45 plus 15 is 60 minus 4 is 56. So we have 56 here. And then 2 times 7 is 14 over 3. We have an LCD of 15 here by multiplying the denominators as 5 times 3. Then simplifying, we have 15 as the LCD, least common denominator, divided by 5 is 3, times 31 is 93. 15 divided by 3 is 5, times 14, and that is 70. And this is understood 56 over 1, so 15 divided by 1, 15 times 56 is 840. So adding up, 840 plus 93 minus 70, you have a total of 863 and divided by 15. So this is now our definite integral for this example. Now for our next example, if you are dealing with a quantity, so it's not the same as if you have an integral using power integral by single term. So we have it here as a quantity. So we have an integral of quantity 2x minus 5 raised to square dx. So using the general power integral or by substitution, so we can consider this quantity as our u as 2x minus 5. As we discussed, we always have to verify if the derivative of the u is given in the integral. So getting the derivative of u as 2x minus 5, then the derivative of 2x is 2dx. Then upon checking, the given derivative here is only dx. So then in order to complete the du, in order to apply the general power integral as integral of u to the n du, so we can add 2 here, which is a constant, together with a correctional factor as 1/2. So again, we can only add a constant for our du. So if the missing part is a variable, so we cannot use or you cannot add a variable together with its reciprocal. So we can only do that if the given or the missing part of the du is a constant. So this is now an integral of u to the n du. So we can add now 1 to the exponent. So this is becomes 2 plus 1 and this is 3 over 3. So we have 1 half times 1/3. So we have 1/6 and the quantity 2x minus 5 raised to 3. Now, substituting the limit, it should be the upper minus the lower limit, but it should be the upper first, substitute to the quantity, minus the lower, substitute to the quantity. So it becomes, we can now consider the 1/6 as our coefficient here, and then we have 2 times 1 first minus 5 raised to cube, and then minus the lower limit, which is 0, so 2 times 0 minus 5 raised to cube also. So simplifying our answer, we have 2 minus 5 is -3, and this should be raised to 3. And for 2 times 0 is 0 minus 5, so this is -5 raised to cube. And -3 raised to cube is -27. And then minus, but raised to cube for -5, this is -125. So we can have now negative times -125 is positive 125. And then minus 27, we have 98 over 6. Or we can reduce this by 2, then our answer is 49 over 3.